Hello students, today we'll be telling you about what is the meaning of line, the vector equation and the Cartesian equation of a line in 3D. If you have already studied 3D, then you know about direction ratios and direction cosines. I'm taking one frame for you, and that is a three-dimensional frame. Your wish. You can take x-axis to be the horizontal, or you can take z-axis because it's a three-dimensional system. So three x's are mutually perpendicular. So you can take any to be x, the other one will be y, and the third one will be z. So this is a system, this is a frame. And this is a line. Line anyway is a set of collinear points. I take one point on it, point A. This is the point through which line is passing. If I have to convert this into vector equation, then there has to be a position vector assigned to it. So I take OA to be the position vector. Of point A through which line is passing. Then to create the locus, there is a current point or a moving point, or we call it a principal point. And because it is vector, so there is position vector assigned to it. That is OP. Now, I can take OA as A vector and OP as R vector. Now, what we doing, we are drawing a vector M. And you know that every ordinary vector, free vector, ordinary vector contains direction ratios. That's why it's a vector, because it will have a magnitude as well as direction. So the distance is visible, the segment is that distance. So we are saying that M vector contains the D ratios. Now we generate AP vector, which is OP minus OA with the help of position vectors, or using the triangle law. AP vector is OP minus OA. So I can take this as R minus A. Also, AP vector and M are both parallel. They are like vectors. So whenever the vectors are like, there is a ratio in them. I'm taking that ratio as lambda times of M. And now can you connect equation number 1 with equation number 2? That is R minus A vector is lambda times of M vector, and hence R vector is A vector plus lambda times of M vector. So this is the vector equation of a line, one-point form. So I will call it vector equation of a line in 3D, obviously. And this is one-point form, because we were given 1 point and obviously a vector parallel to AP, and that vector contains the D ratios. So A vector is the point through which line is passing, that is the position vector, and M vector is the vector containing the D ratios of the line. Thank you. Now coming on to the Cartesian form, I'm using the same diagram. The only difference is I'm now taking the coordinates instead of vector. So this is point A through which line is passing. So I've taken the point as fixed point x1, y1, z1. P point is x, y, z, the moving point. And there is a vector parallel to it, or a segment parallel to it, or a line parallel to it, containing the D ratios as A, B, C. Now, what are the DRs of AP? It is very simple. X minus x1 is to y minus y1 is to z minus z1. At the same time, if two lines are parallel, then their d ratios are equal or proportional. Therefore, x minus x1 upon a will have the same ratio for y minus y1 upon b, and that will be equal to z minus z1 over c, and that is some constant lambda. So this becomes the Cartesian equation. Now this is the Cartesian equation of a line in 3D, and this is also one-point form. Okay, now initially we will learn their examples, and then we will try to connect them. Now what is the connection between them? Vector equation. For example, line is passing through 4i minus 2j plus 7k, and it is containing d ratios in vector m as I minus 5j plus 7k. Then the equation of the line will simply be, that is 4i minus 2j plus 7k plus lambda times of I minus 5j plus 7k. This is enough. Or you can further take this to this form. It is not necessary, but if you want, you can also club ijk, and can you see that the line is now looking as merely a coordinate, arbitrary coordinate, and this is very important. That line in 3D appears as arbitrary coordinate, and because these coordinates will keep on changing and they will be collinear, so it will be a cluster of collinear points. So now I will take example in Cartesian form. Cartesian equation. Say the line is passing through the point 4, minus 2, 7, and line is containing the d ratios as 1 is to minus 5 is to 7. Now, what is the one-point form? X minus x1 over a. So these are a, b, a is to b is to c. And this is x1, y1, z1 is equal to y minus y1 over b is equal to z minus z1 over c is equal to some lambda. So the equation turns to okay. Now, if you want to convert this into arbitrary point, this is enough in the Cartesian form. But if you want to convert this into arbitrary point, then you can equate x minus 4 to lambda. So x will be lambda plus 4, and y will be 5 lambda minus 2, and z will be 7 lambda plus 7. But can you now relate the two equations that they are same? In one I took vector, in the other I took coordinate. Now, how we can relate them? Obviously, they are same, but how we can relate them? Now, if I write vector equation as and Cartesian equation as then this m vector is actually now try to relate. The d ratios in the Cartesian form are in the denominator, but it is a ratio. Though the vector form appears as equation, but as we convert this into three components, it will emerge as a ratio. So m vector is the d ratios of the line. Now, what is x1, y1, z1? Concentrate. That is the point through which line is passing. And what is your x, y, z? The principal point or the moving point, that is r vector. So if you give me one example, x minus 5 over 2 is equal to y plus 1 over minus 5 is equal to z minus 11 over 7, and you tell me how to convert this into vector form. This is very simple, because my m vector will be, can you do it? My m vector will simply be what? 2i minus 5j plus 7k, and a vector through which line is passing is 5i minus j plus 11 times of k. So equation will simply be 5i minus j plus 11k plus lambda times of 2i minus 5j plus 7k. So this is how you can relate that they are same. If you like this video, kindly thumbs up and share. Do subscribe our channel. And if you have any doubts in this topic, write whatever you want to know in the comment box. Thank you.